Okay, so in this module, we're trying to use elimination to solve for different variables. And we'll, in most cases, need at least one scale factor to manipulate one of the equations. Here's what I mean. In this first example, and I'll write a little bit larger for us, we have 3x minus 3y equals negative 3. And then we have negative 2x plus 6y equals 34. Well, in order for elimination to work, the x's or the y's here need to be opposites of each other. And we don't have that. In the top case, I have 3y and 6y, and then I have 3x and negative 2x. So 3x and 2x, they would need to both equal, let's say, 6x in order to subtract one from the other, or one is 6x and the other negative 6x in order for them to cancel out, or any other multiple. But because we have 3 and 2, to reach 6, we have to multiply one of them by 2 and the other by 3. That's 2 steps. I notice that 3y here goes into 6y. So if I double 3y, right, elimination will work. And here's what I mean. So, right, I want to clear this off here. Okay. Clear the first equation, actually. And now, if I double everything, so instead of 3x, I get 6x. Instead of negative 3y, I get negative 6y. I'm just doubling. And then instead of negative 3, I get negative 6. Watch what happens when I add. If I add these two equations, right, 6x and negative 2x, well, that's 4x. But now negative 6y and positive 6y, those add up to be 0. We've eliminated one of the variables. Negative 6 plus 34 is 28. Divide both sides by 4 and we have an answer for x. X is 7. So in this problem, by getting the two y values to be opposites, we can just add and eliminate that variable. Now I just use the x equals 7 to finish. I can plug this into either equation. I'll choose the first, 3x minus 3y equals negative 3. Of course, we can also plug that in here to the scaled up version, or the other equation, and we'll get the right answer for y. Our input's x, so 3x, or 3 times 7, minus 3y equals negative 3. 3 times 7 is 21, minus 3y equals negative 3. So I'll finish solving that right here. So again, we have 21 minus 3y equals negative 3. To solve for y, I'm going to subtract 21 from both sides, right? So we have negative 3y, 21 minus 21 is 0, that cancels out. We're subtracting 3y, that's like negative 3y, and that equals negative 3 minus 21, that's negative 24. Divide both sides by negative 3, and we get our final answer. Negative 24 divided by negative 3 is a positive 8. So x is 7, and y is 8. The next problem, we see something similar. Although here, we're going to definitely require 2 steps. Here's what I mean. We have 4x minus 3y equals negative 26, and then 5x minus 4y equals negative 35. So the two y's, the coefficients are 3 and 4, and the coefficients for x, the numbers being multiplied, are 4 and 5. 4 and 5, right, need to be scaled up in order to equal a common multiple, and so do 3 and 4. The difference in the previous case was that 3 went into 6, which is a nice thing to happen here. One coefficient went into the other. Here, because these two numbers, right, one coefficient is not a factor of the other, in other words, none of the coefficients go evenly into the other, we do have to multiply both equations. I'll use the 4 and the 5, or the 3 and the 4. It doesn't really matter. I think I'll choose the 3 and 4 though, because what will happen is I'll multiply the first equation by 4 and the second by 3. If I chose the 4 and 5, I'd have to multiply by 4 and 5, or in the order 5 and 4, because those are bigger numbers. I'm going to avoid them. So again, when you have two different coefficients like 3 and 4, if you want to get a common multiple, just multiply each coefficient by each other. So I have 3 and 4 here. Multiply 3 by 4 and 4 by 3. But, you have to keep the whole equation balanced, so everything must be multiplied by 4 or 3. The first equation becomes 4 times 4x, that's 16x. 4 times negative 3y, that's negative 12y. And 4 times negative 26 is negative, well, 4 times negative 20 is negative 80. And negative 4 times 6 is 24, so that's negative 104, and we're almost done. Here, 3 times 5x, 3 times negative 4y, well, that gives us 15x minus 12y, and then 3 times negative 35 is negative 105. Now what's going to happen? Well, here we don't have opposites, so we're going to subtract one from the other, right? And that just means we're going to subtract the second equation from the first. 16x minus 15x, what's x? Negative 12y minus a negative 12y is negative 12y plus 12y, which is 0. Negative 104 plus, then we have negative 104, minus a negative 105, that's plus 105, and that's just 1, so x equals 1. Take x, plug it into either equation. I'll choose the first. We have 4x, or 4 times 1, minus 3y equals negative 26. That means 4 minus 3y equals negative 26. Solving for y up here. So we have 4 minus 3y equals negative 26. I would subtract 4 from both sides. Negative 3y equals negative 30. Divide both sides by negative 3. And y equals, well, negative 30 divided by negative 3 is positive 10. And we're done. So x is 1 and y is 10. And you can plug that in here to make sure it's true, either equation. I'll plug it in this second just because we didn't use it yet. 5x, so 5 times 1, minus 4y, it's 4 times 10, should equal negative 35, and it does, right? 5 minus 40 is negative 35. And if you're not really sure, you can plug into both equations. However, I will leave that to you. Thanks.